Hello, everyone. Welcome to another day of awesome physics. What we're going to do is we're going to pick up where we left off in the notes. And I ended on a tricky question. And I'm going to go in a little bit more detail on how I got the answer I got. And we will move on from there. Okay. So my question was, you drive 4 miles at 30 miles per hour, and then you drive another 4 miles at 50 miles per hour. Is your average speed for the 8-mile trip greater than, equal to, or less than 40 miles per hour? Okay. Now, how to solve this problem? What I did first was I calculated the amount of time it took for each car to travel. So my first one traveled 4 miles and at 30 miles per 1 hour. Okay, my second one traveled for 4 miles, but he traveled at 50 miles per hour. Okay, so when I solve this, it took my top guy 0.13 hours to travel in that distance. Took this guy 0.08 hours to travel that distance. Okay, now to find the average speed, it is the distance over time. Okay, so my total distance was 8 miles over my total time, and in this example, I would have to add up both of my times. So if I add up both of those, I'm left with 0.21 hours. Okay, so if I calculate this, I end up getting my average speed to be about 38 miles per hour, which is in fact less than 40. And that's why the answer is C. Okay, hopefully that helped out a little bit. Next, Jim and Harry are having a race to get to Cindy's house. Cindy's house is 600 meters away. Jim runs as hard as he can, but he only runs at a speed of 5.3, while Harry, in the yellow here, he jogs at a speed of 8.2 meters per second. How long will Harry have to wait for Jim when he gets to the house? All right, so if you have to pause the video here to solve it, you can. Okay, but I'm going to solve it here. So what it looks like, all right, what it looks like is Harry he travels 600 meters at a rate of 8.2 meters per 1 second. All right, where Jim travels the same distance, 600 meters, but he travels a rate of 5.3 meters per second. Okay, so when you solve these, Harry takes about 73 seconds. Jim takes about 113 seconds. So Harry waits the difference between these two amounts. He waits 40 seconds. Okay. All right. Going to move on. Okay. So there's a lot of people running a race. Let's see. Cindy, Harry, Kiki, and Jim are participating in a 4x100 relay race. Cindy burns everyone and runs the first 100 meters at a speed of 8.7. So Cindy ran 8.7 meters per second. Harry gets the baton and he runs 100 meters in 12.8 seconds, which ends up equaling 7.8 meters per second. And if you have to ever pause this video to catch up or solve the problem, just let me know. Okay. Kiki runs her 100 meters. She only runs at 7.2 meters per second, while Jim runs 100 meters in 12.4 seconds. Okay, so I got 8.1 meters per second. Okay, so what is the slowest out of all these? The Kiki at the 7.2. Okay. Next question says, what is the average for the entire team? All right, well, you have 8.7 plus 7.2 plus 7.8 plus 8.1, all divided by 4. I'll plug this in the calculator. I got an answer of 7.95, which is going to round up to 8.0 meters per second is the average. Okay. And last but not least, we have one last question. After the race, Jim starts to ride his bike back home, which is 1 mile away. He travels 0.5 miles. After he travels 0.5 miles, he gets a flat tire and starts to walk the bicycle home at a speed of 2.1 meters per second. If it takes Jim a total of 8 minutes to get home, A, how fast was Jim riding the bike in meters per second before he got the flat? If you need to pause the video, pause it now and solve it. Okay. But to solve this, first I'm going to see how he did walking. Okay. So walking, he did a half mile, 0.5 mile. Okay. I'm going to convert this to meters per second. So I have 1 mile, 1609 meters. Okay. And since he did 2.1 meter for every second, so I'm calculating how many seconds, and I got 383 seconds. Okay. Now, the total time it took was 8 minutes. So if it took 8 minutes, 8 minutes is equal to 480 seconds. Okay, 480 seconds. So if I subtract the total time minus the time he was walking, I get 97 seconds. Okay, 97 seconds. So in this example, I'm trying to find out what his meters per second was. So he did a half mile, 0.5 mile. And if I do a conversion, 1 mile, 1 mile in 1609 meters. Okay. And he did this in 97 seconds. So multiply across, and divide down. Okay. So I have 0.5 times 1609 divided by 97. I got about 8.3 meters per second. Okay. And what was Jim's average speed? What was his average speed? So you take the total distance, so 1 mile, over the total time, 8 minutes. Now I got to just convert it to meters per second. So 1 mile, 1609 meters. Okay. And 1 minute is 60 seconds. Do your conversion, and I got 3.4 4 meters per second. All right, hopefully that wasn't too bad. Try solving those few problems out. Hopefully you're getting the hang of speed and velocity. Okay. And now we did a little bit of graphing. So what we're going to do is we're going to have a quiz over this. And if you guys have any questions, let me know. Shoot me an email, or that's the notes. That's the notes before our first quiz. Okay. And actually, we're going to move on to acceleration, some graphing. We're going to keep moving on. All right. So hopefully you guys are keeping up. If you, like I said, if you have any questions, let me know. And we'll see you later.